So this is linear algebra 4.3. I'm going to introduce spanning set theorem. How we should find the basis for subspace quickly and efficiently. This theorem gonna be show how you can find the basis for the subspace. Let's start this one. Let's introduce spanning set theorem. This is the how do we efficiently find the base from subspace, which meaning is we're gonna remove unnecessary vector from the span set. So S gonna be, guys, here is a set of vectors, then this set gonna be span to make H, okay? Then one of element from the S, Vk gonna be linear combination of remaining vector, then we can remove V of k. Still, that V minus x minus we can remove the Vk, that's span gonna be H. Okay, that's the spanning set theorem. I'm gonna explain this spanning set theorem, how I'm gonna use it with the example. Look at this one. Here is a V1, V2, V3 is a vector. They said right here, guys, that just span V1, V3, V vector make H. So which meaning is linear combination of this vector, guys. Always thinking about linear combination of these three vector. Gonna be H, okay? That's the meaning of span. But here is, they figured out we don't have to prove it here. V3 is, guys, make sure V3 gonna be linear combination of V2 and V1. That case, the spanning set theorem say you remove the V3. So which meaning is H gonna be span V1, V2, and V3. That's the condition. But you're gonna say V3 is linear combination V2, V1. We're gonna say span V1, V2. So that's the theorem say. So we're gonna remove the unnecessary vectors right there, guys. Okay? So we wanna show, what do you have to show? We showed H gonna be span of V1, V2. Now that's gonna be base. What do you have to check? Base. Span, linearly independent. So we have to show V1, V2 gonna be linearly independent. So very easy, guys. C1, V1 vector, C2, V2 vector gonna be zero vector. That you have to show it. So we have find the C1, C2, right? So how can do it? C1, 0, 1, negative 3, plus C2, 4, 1, 0. That's gonna be 0, 0, 0. So when you see this one, C1 times 0, C2 times 4. So you have 4C2. Second is C1 plus C2. Third is negative C1. That's gonna be 0, 0, 0. Can you clearly see? C2 gonna be 0, C1 gonna be 0, which meaning is trivial solution. So we prove V1, V2 is linearly independent. So I'm gonna say V1, V2 gonna be base for H. Guys, go back on the top. So this example showed the how gonna use the spanning set theorem, guys. You have three vector right there, but you're gonna say V3 is gonna be the linear combination of V1, V2. So we're gonna remove it. Remove it. Only take a V1, V2. That's gonna be base for the H, guys. Okay. Next one, let's practice this one. I give the same kind of question. The problem is right there. V1, V2, V3 is gonna be vector. It's R3. So this gonna be span of V1, V2, V3 gonna be H. So we wanna find the three different bases. So depends on the linear combination, we're gonna find different base for the age. So can you do that? First one is I'm gonna say this one is gonna be rewrite this form. Okay, so I wanna solve for V3 first. So you guys read 3V3, negative 4V1, negative V2. So this one is V3, negative 4 over 3V1, negative 1 over 3V2. What I see here, guys, this is linear combination of V1, V2, right? So what are you gonna say? Base 1, first base gonna be, you're gonna drop the V3 because that's V3 linear combination V1, V2. So V1, V2 gonna be one base, 4H. So that's the linear independent. You can easily show it. We did the previous example, right? So second is gonna be now you solve for V2. V2 gonna be negative 4V1, negative 3V3. This case, what? This one is a linear combination V1, V3. We're gonna remove the V2. So another base, you're gonna find it. V1, V3 also is a base, 4H. Let's do one more time, guys. Let's say 3. So this time I'm gonna solve for V1. V1 gonna be negative, oh no, 4V1, negative V2, negative V3. V1 gonna be negative 1 over 4V1, V2 minus 3 over 4V3. So you're gonna say this is linear combination V2, V3. You're gonna remove V1. Base, third base gonna be, you say V2, V3 for H. So this example show you're gonna remove one unnecessary vector from the set of vectors, and then you can find the base for the subspace. This example, we're gonna find the base for column matrix B, guys. So we're gonna quick review. Column B gonna be span of column vector of B. So B1, B2, B3, B4, B5. When you see this matrix already reduced echelon form, let's find the pivot. Guys, quickly find the pivot is right there. That's the column on pivot column. There is no pivot. Here is a pivot. There's a second column is no pivot. Here is a column. That's a pivot. Here is a no. Here is pivot. So this is B1, B2. This is B3, B5. That's the pivot column, right? So then another one. This is P2. Here is B4. So let's check B2. B2 column gonna be 4B1. And you see the linear combination of B1. B4 gonna be linear combination B3, negative B3. So remove that column, guys. So we have B1, B3, B5 gonna be span column B. Guys, make sense? Find the pivot column. Another column is linear combination of pivot column. So that's it. You clearly prove, guys, P1 is 1, 0, 0, 0. P2, 3 gonna be 0, 1, 0, 0. P5 gonna be 0, 0, 1, 0. Are linearly independent. Okay, so what are you gonna say? B1, B3, I'm sorry, B5. B5 is base for column B. Okay, when you have reduced echelon form, very easy to find the base for the column B, guys. For example, we don't have reduced echelon form. That's the column A. We want to find the base, okay? So previous examples say column A gonna be span column vector of A, A1, A2, A3, right? So what is A1, A2, A3? Here is A1, here is A2, here is A3. It's very hard to find which column is linear combination of the other column. So what you have to do, guys, we have to reduce this metric to the reduced echelon form, guys. That's what we have to do here, guys. Let's do it this one. 1, 3, negative 2, 0, 4, 0, 1, negative 2, and 2. So first you're thinking about pivot, okay? So here is 1, that's fine. So we have make this one is 0. This guy should be 0. Second column is this is a pivot, that's make 1, right? So this bottom gonna be 0. That's you have to, this is 1, this is 0. Then this should be, after that we're gonna do, think about it, right? That's reduce the, let's do the row operation. Excuse me. Let's do it that way, guys. Okay. So what do you have to do first? I want to do this one is 1, make 1. You're going to do this one is 0. So let's do the 1 over 4 R2 going to be R2. That's like the first. So 1, 3, negative 2, 0, 1, 0, 1, negative 2, 2, right? So one more thing we have to do. This one going to be 0, right? So you're going to be negative 1 R1 plus R3 going to R3. So you have to 1, 3, negative 2, 0, 1, 0, 0, excuse me, negative 5 and 0. That's you have to, that one. Now this should be, this guy gonna be 0, right? So you know how to do it. 5R2 go to, oh no, plus R3 go to R3. That's you have to do it, right? So you have 1, 3, negative 2. So 0, 1, 0. Here is 0, 0, 0. Okay, now can you see that? So which one is gonna be, guys? Still we not really see it. Guys, look at this one. Let's see, this is reduced echelon form. This one is B1. This is B2. This is B3. Guys, which column gonna be linear combination of the other column? Can you clearly see this one? Because they don't have pivot, so you're gonna see P3 gonna be 2 times P1. So another way you see, here is a pivot, guys. Look at this one. Here is a pivot. Here is a pivot. Only this column gonna be doesn't have pivot, so P3 gonna be linear combination of B1. So that's corresponding column of A gonna be A1, A2. So now A1, A2 gonna be base. Okay? So we're gonna say A1, A2 span column A because P3 gonna be linear combination of B1, which means A3 gonna be linear combination of A1, A2. So that's we say A1, A2 gonna be span column A, and then clearly you're gonna prove it. A1, A2 gonna be linearly independent. So we're gonna say A1, A2 is base for column A. So briefly summary, guys. So what you have to do, you're gonna have the vector. So change into the reduced echelon form and find the pivot. So some column doesn't have pivot. That's gonna be linear combination of the other columns.